Okay, so if you are using this movie to preview the lesson and do the guide notes, you may want to fast forward through some of the problems, or you can listen to them all. And I'm also going to do the problems that we're going to do in class. Actually, not tomorrow. I think it's a few days out from now. I'm trying to actually get a little bit ahead on these lessons. So, 4.2, applying congruence in triangles. Excuse me, you will identify congruent figures. So, when are two angles congruent? When they have the same measure. I'm going to need a calculator, so I might as well take this out now. Math tools, calculator. Okay, so in triangle ABC, if A is 64 degrees and B is 71, what's C? So I'm going to start with 180, subtract 64, subtract 71, and I get 45. The answer is C is 45 degrees. Next problem. What property of angle congruence is illustrated by the statement if angle A is congruent to angle B and angle B is congruent to angle C, then angle A is congruent to angle C? That is the transitive property. Yes, it's of congruence. Okay, so you can read through this. You can pause if you want to. I'm not going to read this all aloud to you, but this is part of what you need to fill in on your guide notes. Okay, and congruence statements. I do want to go through these. When the triangles line up, they tell you in order what's congruent to what. So since this says triangle ABC is congruent to triangle FED, that means angle A is congruent to F. B is congruent to E. C is congruent to D. So side AB is going to be congruent to FE. BC congruent to ED. AC, so AC is congruent to FD. So they line up. So in example 1, we're just writing a congruent statement. So, and they mark this up for you. Triangle JKL. So J is congruent to T. They come in the same order there, and you'll see they both have the 2 marks there. K is congruent to S. You can't even read this. L is congruent to R, and the corresponding sides, JK, is going to be congruent to TS. They've marked that for you, but you can also tell because they go in order. And using properties in this figure below, since we know DEFG is congruent to SPQR, they want to find the value of X. Well, X right here is 2x minus 4. That's QR. So that's going to be congruent to FG. So I'll just take this 8 on the bottom, just set that equal to 12. And I think they've done that over here. 12 equals 2x minus 4. So they work that out. 8 is equal to x. You can sub that back in to find your y value, which they do here, I think. I cannot read. There's some problems with the symbols. So let's just work this out. It is 6y plus X is Q, and Q is congruent to F, which is 68. And they told me that 6y plus 8, they said 8 was equal to X. So 6y is equal to 60. Y is equal to 10. Which may be what they were showing here. It is what they were showing here, but there's problems in the symbols as they imported from PowerPoint into the Promethean software. Okay, painting. Divide the wall into orange and blue sections. Will the sections be the same? So they want to go through this. For the diagram, A, B, C, and D are all equal to each other because they're all right angles, okay? And all right angles are congruent. That's the right angle congruence theorem. Okay, so lines perpendicular to a transversal. So you know that AB has to be parallel to CD because this line is perpendicular to it, this line is perpendicular to it, so they have to be parallel to each other. So this all starts getting marked up. And you can actually see the markings. This is congruent to this. There's 2 here. It's congruent to that. This side is congruent to this side. This side isn't marked because by the reflexive property, JK, the orange, is the same JK on the blue. Erase my markings. Okay? And the diagram shows all these, so all of the corresponding parts are congruent. So it does go in the order A, okay, so we have to have J, K. So if I do A, J, K, D, over here, AJ goes with C, K, J, B. Okay, so A, J, K, D goes with C, K, J, B. I want to erase that so it's not up there for when we do this in class. Okay, so here's some guided practice. Identify all pairs of congruent parts. So A is going to be congruent to C. B is going to be congruent to D. G is going to be congruent to E. H is going to be congruent to F. Those are all the angles. AB is going to, okay, so let's look at that. So we just said the angles, A to C, B to D. I'll move this all out of the way and we'll go through this. A to C, B to D, G is congruent to E, H is congruent to F. For the sides, AB is going to be congruent to CD because those are the first 2 here. Going to be congruent to the first 2 here. BG is going to be congruent to DE. GH, EF, and then AH is still a side there, is going to be congruent to CF. Yes, the kids asked if I had a dog. That's my dog playing in the background. Okay, so in this diagram, they give us 4x plus 5. They want us to find the measure of angle H. And H is congruent to F, which is equal to 105. Okay? So angle H is going to be 105 degrees. But if I want to find X, I'm going to get 4X is equal to 100, and X is equal to 25. Okay? So you can see I did those right. I pull that all the way. I don't know if you guys can also hear Ryan yelling in the background, playing some video game. Other side of the house, he's very loud tonight. Okay, in this diagram, you want to show that A, B, G, H. Well, I'm not, oh, that's for something else. They want to show, I don't know what that is. Show that P, T, S is congruent to R, T, Q. Okay? Well, we know that this angle is going to be congruent to that angle, correct? Because they're vertical angles and they're congruent. Now, if this line, you can see that symbol there, is parallel to this line. So those are parallel. This line is a transversal that creates a set of alternate interior angles. So those are congruent. And then these are parallel. This creates a set of alternate interior angles. So from what we're learning today, these are congruent because every angle is equal and every side is equal. Eventually in this lesson, we're going, not this lesson, but this chapter, we're going to show some ways, find some ways that we can show congruence between two triangles without showing that every side is congruent and every angle is congruent. Okay, and that's where some of you saw that. You even mentioned it when we were doing the USA test prep, where you saw like ASA or SSS, that stands for angle side angle, or side angle side. You'll learn all those, and that's what we will be doing in this lesson, in this chapter. I keep saying lesson, but in this chapter. Okay, there's a third angles theorem. It's really kind of obvious. If two angles of one triangle are congruent to two angles of another triangle, then the third angle is going to be congruent. Makes sense, because if you start with 180 and you subtract two numbers, you're going to get the third number each time. So we're actually going to use that theorem. I actually can erase this because this is just an example. This isn't a guided practice. There's just a lot here. So angle A is congruent to angle B. So if angle A is 45, B is 45. This angle is congruent to this angle. So this is 30, this is 30. Okay? So first of all, we can find the third measure of this, if we wanted to, by having 180 minus 60 is 120. Okay? And then if this is 120, then this is 180 minus 120 is 60. Okay? And then if we use our calculator here, 45 plus 60 equals 105. 180 minus 105 is 75. And 75 plus 30 is 105. Okay, so we find that BDC. Now they also point out that we can do the third angle theorem. Angle A is congruent to B. So ADC is congruent to BCD. Okay? ADC. So this whole thing would be congruent. So okay, so as I said, I went through and found it a little bit different way, not using the third angles theorem. Okay, Ryan, do you want to say something to the kids watching the geometry video?
I'm laying down.
Okay, he's laying down on my bed. So move out of the way, don't hit my computer. So now we're going to write a proof, and it's going to be a skeleton proof, but they're going to tell you that AD is congruent to BC, and DC is congruent to AB. And they tell you that ACD is congruent to CAB, so the 2 and the 2, and CAD is congruent to ACB. So the 1 and the 1, the 2 and the two sides. They want right now you to prove congruence, proving all 6 things are congruent. Eventually, we're going to learn how to do this, for instance, by side, 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 where if 3 of these, if 3 sides are congruent, then the angles are going to have to be congruent. And obviously, in that case, AC is equal to AC. So that's part of what I'm going to plan even here when I have to prove that 6 things are equal. I can prove that AC is equal to AC, so that takes care of the side. I've proved that all 3 sides are equal. And then as far as the angles, the third, let me go back so you have the exact name, the third angles theorem says that if these 2 are congruent, the third one has to be congruent. So when you plan for a proof, that's kind of what you're doing. You're realizing like, oh, I can show that the sides are the same. I can use this third angle theorem to show that B and D are congruent. So now we're going to put it into the proof, and I left it as a skeleton proof, but I blocked some things out. So right now we're talking about sides. So they gave us 2 sides, and as we said, we can prove the third side is the third side. That's the reflexive property of congruence. We haven't really used that property much, but understand that that's what it is. Then, to prove the other angle is congruent, angle B is congruent to angle D, we can use the third angles theorem. So if all the sides are equal, are congruent, and all of the angles are congruent, then that's the definition of a congruent triangle. As I said, we're going to learn in this chapter how to do it by only proving 3 things that follow a theorem are congruent. We don't have to always find all 6. Okay? And guided practice number 4. You want in this diagram to find D, C, N. Well, obviously, these two are going to be congruent because they're vertical. So if 68 is congruent here, then this purple one must be 75 degrees. Okay? And by the definition of congruence, what additional information is needed to know that NDC is congruent to NSR? Now, I'm going to tell you that you're going to learn a theorem called angle, angle, angle that's, never mind, angle, side, angle, and a few other ones that you'll be able to know they're congruent with just the information given here. Like once you know that these two are congruent, you can do angle, side, angle. There's some things you can do. But right now, you found that 3 of the angles are congruent, okay? So you still would need to find that the 2 sides are congruent. At this point in the lesson, in the chapter, I'm not going to worry about that too much because that's going to change later on in the chapter. Here are some properties of congruent triangles. The reflexive property of the congruent triangle, okay? It says if ABC is congruent to ABC, okay, if I put them in different order, ABC is congruent to DEF, then triangle DEF is congruent to ABC, so I flipped the sides. This one was on the right before, now it's on the left. And then the transitive property of congruence. Let's go over the daily homework quiz. So, A is congruent to D. Okay, they want to find A. A is congruent to D. B is congruent to E, so B must be 80. 40 is labeled. So if I start with 180, minus 80, that's 100. Minus 40, so angle A must be 60. Okay? EDF. FD is congruent. Okay, here they were asking for the measure. FD is congruent to CA. And if they want in the order of EDF, that would be BAC. So understand the first one they're asking for the measure of a missing angle. The other two they're asking for what they are congruent to. Okay, and they want to write a congruence statement for the 2 small triangles. Explain your reasoning. So let's look at this. Well, WX is going to be congruent to X, Y, right? But since W and Y are equal, are congruent, I need to rewrite this to say YX, correct? Now the Z is next to the W, and the Z connects with the Y. Z is congruent to Z. Angle W is congruent to angle Y, so this, and that's not actually X. Well, that is in the triangle. It's angle WXZ. Okay, so we went through each of these, and we got, in the end, triangle. They wrote WXZ. WXZ would work also to YXZ. Either of those works. And that was the end of the daily homework quiz. So you should be able to do enough to do your guide notes and also skip back through this and watch the problems that you need to go back over to be able to do the lesson.